Hey, ladies and gentlemen, today we're going to talk about the area of our quadrilaterals that we've been studying. So we're going to start off with the area of a rectangle. And this was meant as a GeoGebra discovery type of deal, but we're going to use it a little bit differently, and that's okay. So for the most part, we kind of know that area of a rectangle, if we have a side that is 10 by 10, it says the area is 100. 10 by 8, the area is 80. So we all kind of know that our area is equal to your base times height. In a rectangle, if we have a square, we can use the same formula. It's just your square, all sides are equal. So traditionally we say your area of a square then is going to be like your side squared, which is still just base times height. It just happens to be that your base and your height are exactly the same. So let's look at area of a triangle and see how the area of a triangle is related to the area of a rectangle. So we have our triangle. Oops, and if I scroll this hint, you'll notice that we create a rectangle. So since our rectangle's area, since the rectangle area is base times height, triangle, like this part of it, is only half of it. So the area of a triangle is just 1/2 base times height. And so if we kind of scroll back our hint, there's our triangle. When we create two of them and put them together, we create a rectangle. So your triangle is just half of the area of a rectangle. Alrighty, let's look at our parallelogram. So many of you probably recognize to remember that your area of a parallelogram is your base times height. Now the tricky thing with a parallelogram is that like your base is there, and then your height has to be perpendicular to the base, and your height drops down to a base. So that's a base, and this also could be considered a base because remember your opposite sides in a parallelogram are congruent. So, but your diagonal sides here, like this is not a base because the height is dropped from letter F down to the other segment. So this is your height, and then one of those would be your base. Now, if we kind of scroll our hint over, and we kind of take that, like this part, and we move it over, we create a square or a rectangle. So you've got your base, and then now this height of 5 is the height of the square. So that's just kind of a little extra like how you know that it works. So there's the parallelogram. I can make it look like a square and not change the area at all. So your parallelogram is just base times height. Just be really careful with this in that your height is always a perpendicular line dropped down from a point. Okay, and the last one that we're going to be talking about for our class is trapezoid. And I really like this one. This is kind of cool. So you have your height. So again, like with your parallelogram, your height is a perpendicular line dropped down from a point. And then your bases in the trapezoid are your parallel lines. So you have your base 1 and your base 2. When I scroll this over, I'm going to copy the trapezoid. And I now have 2 of them, and I've created a parallelogram. So the trapezoid initially was only one of them. So in my area of a parallelogram, remember is base times height. We have our height. Now in our base, in this case, is going to be, I can put down my height here, the base 1 plus the base 2 of that trapezoid. Now the other thing though, remember, is this parallelogram is 2 trapezoids. So if I want the area of one of them, I just need to take 1/2 of it. It's not the best writing there for my formula. So my area of a trapezoid is 1/2 of your height times base 1, base 2, or plus base 2. You might also see it as like base 1 plus base 2. Oops, that's supposed to be a subscript. Times your height divided by 2. You might see your height in front. It doesn't really matter where it is. Either way, these work. And if you didn't quite catch all those formulas, I am going to also post up on this video or underneath the video in Schoology. I'm also going to post up a list of that part of your formula sheet that does have all those formulas. So you can refer back to them then. I just wanted to give you a little heads up as to why these formulas are the way they are. If you have any questions, message me.